Good evening. Now we are going to be with second video, which is on our term work. If you remember in first video, we are with four parts of first sheet, and we have that as hot rolled section, then classification of section. Classification we have two. One that is classification due to cross section, due to dimensions of this, that is B by TF and D by TW. And from this, we are going to classify this figure 2 halt road section. We have seen. Now we have this will be highest halt road section is ISWB 600, and we have this value something 4371 ZP value, that is centimeter cube. Then bolted connection we are so we have seen this and different types we have seen. We have lap joint, we have butt cover joint, that mainly we have seen, and then we have chain bolting and staggered. And in staggered, how to calculate the values, that we have to see in. So this you will get in tension member. Then we have welded section, and mainly we are going to use that is fillet weld. So we have different types of weld. We have V, double V, J, double J, U, double J, bevel, double bevel. So we have like this different types of welded connection, but we are mainly interested with fillet welded connection. And now we are going to be with sheet number 2, which content that is tension member, cross section of tension member, cross section compression member, buckling class, and then we have this as effective length. So we have to go with these 4 in sheet number 2. So now I will go directly to sheet number 2. And in this sheet number 2, we have first part, that is cross section for tension member. So we have this all rolled section cable we are going to use. Then group of wires we are going to use. Then we have this rolled section. We can use this circular bar, maybe solid or maybe hollow. So here we have seen solid. Then we have square or rectangular tubes. Then we have single angle section, then channel section, then eye section. So all these are rolled section available. Then we have built up section also. We have double angle sections connected back to back. Then we can have that is connected back to back on opposite side of gusset plate. You may have on same side of gusset plate. Then this you can say as a star angle, so that you can keep in mind. Then we have this as channels back to back. Then you can have channel face to face. So we are going to use this section. Now when we will go for this, so generally we will go for this when our rolled sections are not going to satisfy our requirement, and in that case we have to go for built up sections. Now main thing we have to keep in mind while we are going to design this, we are going to use that AG required. Now already you may have gone through oral questions which I have in playlist, and there you can see all this. So we have that is AG required, that is equal to T into gamma MO upon F5. I already mentioned over there. We have formula that is in section 6. TDG is equal to AGFY upon gamma MO, and we are going to modify it, and we are going to mention AG required equal to T into gamma MO upon FY. And by using this, we are in position to calculate this value of AG required. So here we have to keep in mind main two things, that is AG required we are going to calculate from here, and our Fy value is constant. Now in this, if we will go to second part, that is, or we can say we have different TDG, which is in 6.2, that is yielding of cross section or strength of tensile strength of section by yielding of cross section, and we have this Ag Fy upon gamma m. I will not go in detail. Then we have TDN, and in this we have to find that is A net. So keep in mind here we have to find net area, and our stress is constant, which is Fy, and this is generally we have 250. That we have to keep in mind. And actually this Fy 250. So if we will go to table 1, now this also we know. We have table 1, and this table 1 we have, that is properties of the material. Properties of material. And from this you are going to get different properties of the material. If we will go to our videos which are on steel structures, that is design of steel structure playlist, and in that one we have in detail, I have mentioned there all tables with page number, and you can have that one review on that one. That is table 1 we have for properties, table 2 we have for classification of section, and then we have table 3 slenderness ratio, table 4 and table 5 we have, that is partial safety factors for materials and for loads. Then we have, that is table 6 deflection limit. So likewise we have these different tables, and we should know this table 7 perfection factor, then 8 ABCD we have reduction factor, 9 ABCD we have FCD. So likewise we have 10 buckling class, 11 slenderness ratio. Then table 12 we have, that is K1, K2, K3 values which we require for compression member. Then 13 AB we have for FBD, 14 we have for FCRB, and then 15 we have for effective length for flexural members. So mainly we are interested with these 15 tables, and you may have asked that you know which tables we are going to use and for what purpose. So we should be in position for this. Now you can see for your compression member, so cables we are generally not using, that is for compression member. Then we have other all sections which we are using for tension member, we are going to be using it for compression member. So these are again rolled section, and then we have built up sections, we have different, that is beam section with plates. Then we have again that double angle section, star section, then channel sections, back to back, face to face, then two eye sections. Because compression, now keep in mind, if you remember, just we have seen in tension member we are going to use we are going to find A net, and then Fy we have constant. So this is area and this is stress. Now if we will go to compression member, then we have generally, this is AE effective area, and we have effective area for plastic section, for compact section, for semi-compact section, AE is taken as AG. And as compression member, we have AG constant, and in compression member stress we have to find out FCD. And tables we are going to use for this, that is 9 ABCD, and by using that table we are going to find out the value of FCD, and then we have that formula if you will see. So we have AE into FCD. So when you have question, what is difference between tension member and compression member, do not answer tension members are going to take tensile force and compression member is going to take compression force. No, these, when they are going, question will be asked, what is difference, means you have to answer technically. That is not technical answer, that tension member is, that name itself shows that tension member is for tensile force and compression member is for compressive force. So you have to mention, you have to answer these two. For tension member we have to find net area, and for compression member, for these three, our area, that is gross area of cross section. Now in tension member, stress we are going to consider value of Fy, whereas in compression member we have to find value of stress which depends upon L by R. L is effective length, R is radius of gyration. and we have radius of gyration, we are going to calculate, that is I by A. So likewise, we should be answer properly. Now he may ask, when you will go for built-up section. So I already mentioned, when our rolled section, so two criterias. So one, when ZP required greater than ZP available, and we have seen this is ISWB 600, and that is something 4300 centimeter cube. And second, you have when sometimes you have restrictions, some restrictions are given. In that case, you have to go for built-up sections. So likewise, we have to go for built-up sections. Now we have third, that is buckling class. Now see, buckle classification, we have two. One classification that is in table 2, which is related with your values, that is for AE. So keep in mind that we are going to use that classification to decide the class, that is plastic, compact, semi-compact, and which will decide your effective area. Now second, we have buckling class, and by that buckling class, we are going to find value of FCD. So in FCD, this buckling class plays important role because on this buckling class, our imperfection factor that depends. And by that imperfection factor, we are going to find the value of FCD. If we use table, then we need not require that buckling class. Means we need not require that values of buckling class. Here, we are going to use table 8A, B, C, D. So 8A, it shows for class A, 8B for class B, 8C for class C, and 8D for class D. So likewise, we have this for buckling class A. 9A we are going to use for FCD, 9B, 9C, and 9D. So we have for our section, these criteria are given: H by BF. This value should be greater than 1.2, and TF, that is less than 40. Then we have buckling about ZZ, we have A, and buckling about YY, we have B. We have to always go minimum, that is buckling class, and your value of this FCD depends on this. Then second, we have that is TF. Here you have two criterias: H by BF greater than 1.2, TF less than 40, or if you have TF greater than 40 and less than or equal to 100. So this is same. H by BF, this criteria 1.2 is same for these two. Then second, we have H by BF less than or equal to 1.2. Here criteria is TF less than or equal to 100. We have this buckling class. And if TF greater than 100, we have this. So likewise, depending upon your cross section, so we have this for built up section, or I will say welded section better. So for welded section, we are going to be TF less than or equal to 40. We have this buckling class for ZZ and Y by axis, and TF less than, sorry, this is TF less than or equal to 40, we have that is C and D for these sections. Then we have cross sections, that is hot rolled cross sections, but these are cold form, and this is hot rolled. And you can see these values for hot rolled cross sections. Buckling class we have for all, that is buckling class is A, and for cold form, so we do not have in our syllabus cold form, we have B, and that these are hollow sections. Now we have next, that is all these solid sections, we have that is channel sections, rolled sections we can say, but solid. And in this, for all these cross sections, we have buckling class as C. Then we have for built up sections. For built up sections also we have this as class C. So here we have welded, and here we have that as bolted built up sections. So likewise, your class will decide which table you are going to use for these cross sections. And from this, we are going to find reduction factor, or we are going to get value of FCD. And then effective length. Now, this you have to keep in mind. Translation, this is related with your displacement, and this is rotation. So, translation and displacement. So, now you have first restraint in translation, restraint in rotation. So, these, if both are restrained, then that support is known as fixed support. So, he may ask you, can you draw the diagram? So in that case, whenever you have fixed end, you have to show slope for some portion. This slope is 0. And we have effective length for this, that is 2L. Then mainly we are going to use 4 conditions. Then we have second, restrained in translation and free in rotation. So this support is hinged support or pinned support. Hinged or pinned. So both hinge and pinned are same. Do not say hinge is different and pinned is different. Now here we have again restraint in translation and rotation. So we have here fixed. Free means this is cantilever. Cantilever end. So here both restraint free means again this is hinge. So when both end hinge, we have L equal to L. Then we have restraint. So both these are restraint, means I have this support as fixed. Now we have restraint for translation, free for rotation, means pinned. And then you can see we have one end that is fixed, so slope is 0. And therefore my effective length is less because my this value is 0. Only in free end, it will be 2L because it will go in this direction. Here you can see no fixed support, so no slope 0 region and L equal to L. And then we have last condition. So we have both ends fixed. So restraint, we have fixed, and restraint, we have this also fixed. And definitely our length should be less because we have this region where we have 0 slope. We have here also region 0 slope, and we have this value 0.65 L. So as your fixed end comes, then your effective length reduces. So if he asked, so only when it is free end, it is 2L. Otherwise, for both end pinned, L, one end pinned, other end fixed as fixed. So 0.8L, when both end fixed, then it will be 0.65L. So likewise, we are with sheet 2, which we are being in our term work. So now we will stop here only. The remaining part we will see in the next video. Thank you.